Okay, good morning, everyone. Hope you're well, excited, and ready for some cool data stuff. So, we'll start with a question of how do you leverage AI technology and talented people to develop a successful, sustainable, and scalable data science practice? So, our opening keynote here is Alex Antic. Alex has 17 years of experience developing across a number of industries and domains, including federal and state government, insurance, asset management, banking, investment in retail, consulting, and academia. He has experience in leveraging data science and AI to deliver impact and change by developing and managing high performance team for both strategic advisory and technical expertise. Recently, he's been recognized as one of the top 10 analytics leaders in Australia by Institute of Analytics Professionals of Australia. So, Alex, you can start.
Thank you.
Thank you.
Imagine living in a world where information about you and the world around you is constantly captured and analyzed. A world where a tracking device is attached to you to influence and even manipulate you. Well, it's no surprise that this is the world that we live in today. You just need to take a look at what's in your hand or attached to your wrist right now and how much information you voluntarily share each day. Just think of social media, the information that you divulge, LinkedIn, Twitter, Facebook, etc. It doesn't take a smart person to realize that the world we're living in today is very different to the one we would have grown up in many years ago, especially someone like me who's constantly aging and getting grey. Organizations these days need to know how to make sense of and extract value from all this data. And it's quite likely that this task is a key part of your current role, and hence why you're at the conference today. But data has been collected about us and the world around us to help inform decision making for a very long time. So, why is it so challenging these days? There are two main reasons for this. The first reason is the type of data that we're collecting, and the second reason is really about scale. So when it comes down to type of data, the issue is really around this notion of unstructured data and the proliferation of unstructured data throughout society. I've heard many statistics that quote that around 80% of all data created these days and consumed by many organizations is unstructured in nature. And by that, I mean text-based, audio, and video. So knowing how to store this data, how to leverage value from it, how to run analytics, especially traditional based analytic solutions, is really non-trivial in many cases. And a lot of organizations really struggle to know, how do I make sense from utilizing our emerging technology in AI and data science to be able to create value from data that we're not used to really collecting and storing? Beyond the type of data that we're also collecting, there's this issue that humans don't scale. Where in the past you may have had a small team of analysts who could use traditional techniques to extract value from your data, we've realized that these days, with the abundance of data that we're collecting and the volume and velocity that we acquire it, we really need scalable techniques to help us inform our decisions on using such data. So the question then is, how do we actually manage all this? And there actually is an easy solution, one that is close to all our hearts. And that solution really is data science. This is where data science comes to the fore and really helps us. There's many definitions thrown around data science. People talk about the technical components, the machine learning parts. They talk about this intersection of mathematics, statistics, computing, and business. But to me, data science is really about change. It's the science of change. That's the way I define it. It's transformational change that is used to enable a data-driven, evidence-based decision-making culture in an organization. And its success ultimately hinges on clear alignment to strategic goals with measurable outcomes. And I'll repeat that again, because if you only remember one thing from my talk, I want it to be this: clear alignment to strategic goals with measurable outcomes. And one of the key reasons for that is if you don't have that clear alignment to what you're doing, to the strategic outcomes of the organization, then it's going to be very difficult to get buy-in and support from senior management. And if you don't have that, well, let's be honest, you won't get any funding. And you also need to have measurable outcomes so you can quantify the results from all the research and work that you're doing to be able to measure those outcomes so you can justify extra funding that you'll be asking for and resources that you want allocated to you. So this transformational change is both cultural and digital in nature, but ultimately it comes down to people. Today, I'd like to share with you the 3 T's that I've identified for building a successful, sustainable, and scalable data science capability in any organization. And as you'll see, the human element is integral to each. And the 3 T's are trust, technology, and talking. So the first T is really around building trust within your organization. And there's two key elements to that. One is people and one is culture. To begin with, you need to have the right people in the right roles. And I like to think of this as a tiered approach. So there's three tiers to this. On the bottom tier, you have your hands-on practitioners. You have your data scientists and software engineers and their peers, people doing the actual work. Sitting above them on the second tier, you have a team lead or a manager or director who's there to guide and support that team. And above them at the highest tier, you have your C-suite support, your CDO, chief data scientist, whatever it is in your organization. Now, this is one of the most crucial parts actually in that tier, because if you don't have senior management support, as we all know, it's very difficult to get a data science project off the ground, to get support, and to get the funding that you need. So let's start with the first tier. That's around your data scientists and software engineers. And I call out these two particular roles as they're the base or the minimum roles that you need in most organizations. Some have other roles, people that translate the data and analytics to inform decision-making, to help inform decision-making within senior executives. Some have business experts or data wranglers, but at its core, it's really the data scientists and software engineers that drive that capability. So with your data scientists, it's important to have people with really strong quantitative skills, people who understand machine learning and model development, and people who are proficient and, of course, very strong in coding in languages such as R and Python, SQL, and more commonly these days also Scala and other distributed platforms. Working alongside them, you have your software engineers. These are people who are very strong from a software development perspective. And their key role often is to actually productionize the models that the data scientists are developing. And what I'm seeing more often and more commonly around many organizations, both nationally and globally, is for them to have this strong capability within distributed computing. I think that's a growing area, and one that if many organizations haven't actually taken up, they will in the next year or so. It's important to make sure that you align the tasks that these staff in your team may be doing to their skill sets, interests, and expertise. It greatly helps with retention. And as we all know, that there can be a really high churn rates in many organizations when they get this wrong. So it's really up to us as leaders in this space to make sure that we have the right people in the right roles to ensure adequate and strategic outcomes for our organization. So that's the first tier, the bottom tier, where we have our actual hands-on practitioners. Sitting above them, we have the team lead. And from my experience, this can actually be one of the most difficult roles to fill. You need someone that can actually bring together the technical components from what their team does and align that to the business aspects of the organization. So first and foremost, I believe they need to have technical credibility, or at the very least, a very strong understanding of the fundamental principles of the analytics and technology that drives what their team does. It is possible to have someone who has, I guess, a lack of technical credibility in components of that, but to make up for that, they really do need to have a strong understanding of those fundamental principles. Otherwise, it can be very difficult for them to understand what their team's doing and then to extract the most value from that. I also strongly believe that it really helps for them to have hands-on experience. In some organizations I've worked in, that is actually vital. But in most organizations, I feel that is actually very helpful for them to have been a practicing data scientist or software engineer, to understand what their team does on a low level. And some of the reasons around that is so they can help with sanity checking, they can help provide guidance to their staff and support. But they can also, beyond that, identify limitations of some of the technical solutions posed, and also identify good people, good technical people to build up those capabilities, to be able to vet, what makes a really great data scientist versus just a good one. It's important for them to understand what are appropriate tasks and realistic expectations to expect from their staff. I've seen in some organizations where some of those team leads come more from a generalist background, and where they really struggle to provide their staff with appropriate tasks on day-to-day work or project-specific work, and where sometimes the expectations they provide to their staff can be somewhat unrealistic in terms of either timelines or the level of difficulty of the work that they've tasked their staff with. In addition to that, these people are also responsible for finding the right problems to solve. And to do that, they have to be able to not just traverse the world of technology, but also the business world. They need to work closely with business leaders and senior executives to be able to marry together emerging technology, the great technical work that their team does, with all the pain points and problems that the business is facing. And when you get that right, that's really when magic happens in an organization. And these people are in a really unique position. And I think the great ones really do understand that. They understand that they're in this position where they can see all this amazing, creative work being done in the AI space. And they can then look at the deep business problems that an organization is facing and try and find those particular solutions and to join the two together, which is incredible when it works. And I think many organizations need to truly understand the importance of having the right person in that second tier position. It's also a unique position because they're the people that turn viable business problems into measurable technical solutions. Remember, I mentioned earlier, you need to have this clear alignment to the strategic goals with measurable outcomes. Well, this is the person that comes in and actually does that. They can achieve that goal. They have to identify viable business problems, ones that can be solved via data and analytics. And they have to also be able to look at how do you actually quantify, what metrics do you use to gauge success, so they can present to their senior executives and say, actually, what we're doing, we believe in, and we can actually quantify and show you. The team leader is also an evangelist for data science and AI through the organizations and beyond as well. They're there to spruik the beauty and the creative element and the power of analytics and data science, and to really get people excited by it and to show what can be done. And I think one key element is beyond that is that they need to be seen as a trusted advisor. Many people that move up the ranks from various technical data science roles, they tend to believe that they should only be seen as technical experts. I think the more senior you get, it's actually important to switch that around and not be pigeonholed as just a technical expert, but to be seen as a trusted advisor to not just your peers and other associates in your organizations, but more importantly, to your senior executives. I think that's when you can actually get a lot of buy-in and a lot of support from senior executives when it comes to growing your capability. So they're the first two tiers. You've got your data scientists and software engineers on the bottom. You've got your team lead. Now, beyond that, sitting on the highest tier is your CDO or your C-suite executive. And as I said earlier, without C-suite support, it can be very, very difficult to get data science capability off the ground in any organization. The CDO is the person who promotes and advocates a data-driven, evidence-based decision-making culture. And they often do this by leading by example, through leading by example. And it's up to them to enable data access, sharing, and data democratization. And a key part of that is to break down silos. I've seen in many organizations, both public and private sector, this notion of data silos, of knowledge silos. And often you really need C-suite support to break down those barriers, to get people talking and communicating, and to help people understand that the data isn't owned by a specific group or business unit in an organization. It's really belongs to everyone. I mean, everyone is there to serve the same purpose, to add value to the organization. And to do that, they need to be able to get access to the data. So having someone that can break down those silos, break down those walls, and enable sharing is actually is vital and paramount to success. Another key component of this person's role is to support education and training. One part of that is technical upskilling of staff, but more broadly, and what's becoming even more important these days, is to help promote data literacy. That's across all ranks, but most importantly, I think it's in the C-suite or the senior executive space. And one reason for that is that you have a lot of senior executives who have some vague understanding of what data science is and what AI technology can afford them, but they develop misconceptions, they buy into the hype, and they don't really understand what are clear and realistic expectations of their organization when it comes to utilizing this technology. So having someone in the C-suite who can speak their language but also understands the technology and its limitations is hugely beneficial to helping manage expectations, which is crucial to many organizations when it comes to building that data science capability and doing it in a realistic way. In addition, they create and promote a data strategy, which means that the whole organization has a clear understanding of how data and analytics is used to really drive impact and change to meet their strategic goals. And one final thing around that position is that they're empowered to have ultimate accountability for the data sets and data-driven decisions that are made. So if you're going to have someone in that role, they really need to be empowered and to be able to actually make decisions. And that's actually a point I've seen some organizations that fail in that space because they have someone with a C-suite title, but not the C-suite, capability, which is a real shame. So from a very senior executive position, you need to make sure that they're empowered to make those decisions. When it comes down to culture, which is the second T, around trust, first we talked about people, now we're talking about the cultural element. It really comes down to developing a culture of trust throughout the organization. And there's a few key elements to this. One aspect is developing a culture of innovation, experimentation, and exploration. And this touches on the science element in the word data science. From the Silicon Valley world, often you'll hear this mantra of fail fast, fail cheap, and learn heaps. I think this is actually very crucial in most organizations to be not so risk averse that they stimulate innovation, but they also need to obviously to have governance and support around that. But they need to be able to understand that when it comes to applying data science, especially at scale in complex environments, that to really innovate, you need to be able to have this notion of failing fast and cheap. And by that I mean it's allowing your staff and your data scientists to be able to go down rabbit holes, to make explorations, to research areas that they don't know what the end result will be. You need to be able to explore, have the freedom to do so, and not always come up with an end result that you think is meaningful, because you'll always learn something from that. So as long as it's done in a structured way, I think it's absolutely paramount for success in most organizations. Also, collaboration, a culture of collaboration is very important, both within the team and across different teams and business units. People need to be talking and collaborating with one another, especially when it comes to data scientists collaborating with business owners, so they get a deeper understanding of what are the business problems faced by the organization and how can they use their technical skills to help to address some of those problems and issues. Alongside with collaboration, there's this notion of sharing, not just sharing data between business units and different teams, but also sharing information, lessons learned, and sometimes resources. I've worked in environments where, due to budget constraints, your teams are run very lean. And sometimes if you take on a large project or you see a great opportunity, in order to leverage that and those, grand, once in a lifetime opportunities, you sometimes need to reach out to other teams, share some of their resources, share some of their capabilities, sometimes even share funding. Because as I said earlier, you're all there to actually serve the whole organization more broadly. So we're there to fight the same fight and to meet the same strategic outcomes. So people need to kind of be encouraged to innovate and share information together. Sometimes it's done through advocating that encouragement from senior executives, such as the CDO. Other times it can also be done through formal and informal channels where people get together, meet up regularly, share information, and see how they can help one another out. Having previously also worked in the consulting space, I also find it helpful sometimes to instill in my staff this notion of thinking of yourself as an internal consultant and always asking yourself, how can I better serve my customers? And that doesn't have to be external customers, obviously. That can be internal business units that you work with. I think that helps frame some of the opportunities within an organization and your attitude to how you can help meet those strategic goals, and think beyond just your own team and the work that you're doing. How can I help my peers solve problems that they're working on, so we can ultimately help move the organization forward? When it comes to talking about culture within an organization and data science capability, a question that often arises is, should this data science capability be centralized or should it be distributed? This is a decision that is often informed by a number of factors, most of which come down to 2 points. One is the size of your organization, and the other is the data science and analytics maturity. This often helps steer you in one particular direction over another. I mean, there is no right and wrong answer, but it's important to note that often it'll make sense to centralize the IT function in an organization, but it isn't always efficient or suitable to centralize data science. However, there are some advantages to centralizing the data science capability, and one is that it allows technical support for your data scientists and other staff, and career progression opportunities. I think for most organizations, it's important to address career progression because, as I mentioned earlier, churn can be a problem. So being able to have the right people and the right processes and career paths in an organization is absolutely paramount to retaining your best staff. You put a lot of effort and money into acquiring and then training great staff. You really should be spending a lot of effort also into retaining them. So whether or not you centralize or distribute the capability can have an impact on that. But there are disadvantages too. And one is that sometimes data scientists can feel somewhat removed from the business when there is only one centralized data science capability. And ways around this, that when I've navigated this in the past, was to have some of my staff embedded in business units, especially for key projects, so they can work closely. And that actually works two ways. One is they get a really deep understanding being embedded in the business unit, listening to how the business talks about the challenges and how they talk about the data. So it's very informative for them. But also on the flip side, it gives the business group really good insight into what data scientists do. It helps them develop realistic expectations of what can be achieved through applying analytics to their particular data, which could vary in quality, size, and a number of other factors. And it really helps build strong working relationships, and that can often be really fantastic. So that's the centralized approach. From a distributed perspective, it has its own advantages and disadvantages. So one of the pros is it allows regular and close contact to the business for the data scientists and software engineers. But sometimes the data scientists can feel isolated from the broader data science capability in organizations and from their peers. So they sometimes struggle with that. So having forums and remedy for that, I think, can be really helpful. So people are always talking and spending time together so they can share technical challenges and also business problems that they're facing. However, I think it's important to realize that an organization needs to be sufficiently mature in general before they decentralize, with a clear line of accountability to the central unit or the leader. And there's three reasons for this. One is around governance, the other is around transparency, and the third is around ensuring strategic alignment of what they're doing to what the strategic goals of the organization are. If you get some of this wrong, then you can have a rogue units throughout the organization that are kind of doing elements on their own that don't really match up to what the organization is striving for. So just something important for senior executives to be very mindful of. When it comes to culture and management, one other thing I'd like to note is that it's important to realize that data science is not IT. There is a difference. They have to work together. There has to be a symbiotic relationship between the two. But there is a key difference, and that is that data science is really about discovery, whereas IT is around delivery. One is around solving problems, and the other one is around implementing solutions. Some people incorrectly assume that you can simply bundle data science within IT, but unfortunately, it isn't often that simple. And one of the reasons is what I touched on earlier is that you have to account for the experimentation aspect of data science, the science within the word data science, which is different to the process-driven nature of IT. And once again, fail fast, fail cheap, learn heaps mantra is often helpful. Otherwise, you can be restricted from an innovation and discovery perspective. So the two have to work well together, but there are key differences, and it's important to manage that sufficiently, especially from a senior executive position. So that was the first T, around developing trust through people and culture. The second T I'd like to discuss is around technology. And there are two key elements around technology that you need to get right around tools and data. So with tools, it's important to have open source. I think for most data scientists to work efficiently, they need to be able to access all the R and Python projects and libraries that they need. But you also have to integrate that in such a way that it works alongside any vendor-specific tools you have. So a suite of tools is really the most optimal way to run it, because you need to allow your data scientists to find what is fit for purpose for the particular project at hand. You also don't want to standardize too much, because of variation between projects, there has to be a certain level of flexibility with how you actually manage the tools and deploy them, and how you spin up clusters and instantiations of different tools and libraries, so you can adapt and work effectively in an agile way. As I touched on earlier, it's becoming more and more important to have a distributed data capability. People talk about Hadoop, Spark, etc. I think that's actually becoming much more important, especially in organizations that deal with large volumes of data. They want to look at parallel processing to deal with that. At a more fundamental level, you also need to have the right infrastructure to support varied data sets, think data lakes, and to look beyond traditional relational database management systems, which could effectively only store tabular data. But one of the huge problems around data collection and analysis these days is around unstructured data. So having infrastructure that allows you to hold that data and perform analytics on it, especially in a raw format, is absolutely paramount. What's also really important is to be able to work in an agile and DevOps fashion. And here I'm thinking about that transition from development to production, which can often be challenging for some organizations. So you want to be able to streamline and automate that. So once again, having the right people in the right roles, someone with a data ops or DevOps background, can really help you create that efficient process. So your whole pipeline runs much more efficiently, effectively. You're going from data ingestion to model development to productionizing that model. So being able to predict some hiccups along that path and having the right methodology and processes in place can be extremely helpful. When it comes down to the data itself, there's a few aspects that you need to really be cognizant of and be able to deal with. One obvious one, anyone who's dealt with data, is data quality. As we all know, quality of data can be very varied. So you need to understand how do you actually cope with poor quality data? Can your organization deal with that? Can you still get insights? Can your tools, look at techniques to help change the quality? Can you work with business end users, business owners to help improve the quality of the data long term? Another problem can be quantity. How much quantity are you dealing with? The huge tech giants, of course, quantity is a huge problem for them. For small organization, is quantity really an issue for you? Most likely it's quality and type of data that you deal with that'll be a problem, not so much the quantity, because storage is much cheaper these days than actual capability to deal with it. Other questions that arise are around the type of data. Will you be looking at lots of unstructured data? Do you have the tools and infrastructure to deal with that? But more importantly, do you have the people that can actually extract value from it? And what I see often, especially in certain domains, such as in the government space, is how much of your data will be labeled. Can you run supervised learning techniques on some of this data? How do you actually come up with methods and processes to label your data? There are ways around it. So having systems in place can be really important to build up the quality and viability of your data long term. Another issue is one that we touched on before. It's around access data. Will all your staff have access to the data they need? Are they bound by silos? But in the government space, it can also be security restrictions. Does everyone have access to the data they need? Because of different security classifications. And how do you get around these? So they're important questions for many senior executives to ask when building up this capability. And the last point I'd like to make on data is usefulness. How useful is the data that you have? You may have an abundance of data, but it may not be solving the particular problem that you have in front of you. How do you source other data sets? Can you leverage social media data? Can you buy in data? Can you generate your own? Do you work with synthetic data? Those are just some of the important questions that need to be asked when you're trying to build up a really strong, long-term, sustainable data science capability. We've touched on quality of data, so an offshoot to that is when it comes to cleansing. How do you cleanse your data? What methods will work? Will you be using imputation techniques? Why do you have to clean your data? Can you get around it? Can you look at techniques that don't need cleansing? Dealing with missing values or messy data? And what are some of the ramifications of this, the business ramifications, which is really important to understand, not just the technical. And to answer some of these questions, do you need a data wrangler? Do you need someone who's dedicated to that? Or will your data scientists actually do this as part of their roles, which happens more often than not? Because data quality can vary, it's really important for data scientists to understand that they need to develop models that are robust to data quality. Sometimes, they'll develop models assuming a certain level of data quality, but realistically, some of the data that will be ingested while the model's running would, may, sleep or reduce quality over time for whatever reason. So it's important to be able to identify that and learn how to deal with that from a model development perspective. But when it comes to answering a lot of these questions and knowing how to use data to really add value to an organization, one thing that is absolutely crucial is domain knowledge. So it's absolutely paramount for data scientists to work closely with business experts to understand what the data means and to fully understand how they can leverage that particular the data sets held by the organization to drive strategic outcomes. Beyond that, it's important to have governance frameworks, to be able to manage risk and fraud, and also data lineage, which is becoming even more important these days. And by that, I mean traceability of decisions made. So a particular decision made on a particular day, what data was used, what models were used at the time we're running in production to actually make those decisions. For any organizations which may take people to court, such as in the law enforcement space, it's important to have that data lineage in place. Another aspect which is becoming even more important, and which Alex spoke about at the opening to this conference, is this whole notion around trust in AI and responsible use of AI. So there I'm talking about ethics, bias, fairness. And this is becoming a growing interest for most organizations, but many struggle to know how to actually address this. So I'd like to spend a bit of time talking about how do you actually develop the trust component when talking about ethics in an organization. So by ethics, I mean, effectively, I'm talking about morals that govern actions and behaviors. But for most organizations, what I'd like them to realize is this is not simply a box ticking exercise. Addressing ethics, bias, and fairness in AI is non trivial and can be very context specific. AI, machine learning, more broadly, merely reflects systemic human bias. After all, AI is not inherently biased. But why is it such a concern? And there's two key reasons for this. One is scale. Models can be far-reaching and can reinforce and perpetuate human bias. And the other one is around the potential to hide from our moral obligations and justify moral judgments. Someone turning around and saying, actually, the AI model decided this, or it's biased, not me as the human who owns this or runs this organization. So whilst we can't completely eliminate bias, we can work towards understanding, identifying, and reducing it. So we need to realize that technology alone can't address all these issues. And there's a number of aspects that are important to understand when it comes to working with bias. One is to develop trust in AI, you need to address issues around data, discovery, and diversity. These are really questions and considerations that organizations need to contemplate when thinking of the ethical ramifications. So when it comes to data, you need to understand your data from both a technical and domain perspective and identify potential for embedded bias, and to think, what are all the potential sources of bias in my training data? And is the data fair and representative? Next, around discovery, it's really around developing models to help make decisions. You need to ask, what does fair look like? How are you actually defining bias? Is fairness defined based on the model's inputs or outputs? And when is it deemed fair enough for us to deploy a model? Also, how can these models be attacked, abused, or misused? And is there enough transparency in that whole process and our models themselves? Another question that often comes up is the model explainable? But the questions you need to answer there are, to whom is it explainable? Is it to a technical expert, to a business leader, to your grandmother? I mean, what do you mean by explainability? And also, what is explainable? Are you asking, is the algorithm explainable, the model, or the decisions? And then beyond that is, how much do you need to understand how it works in order to trust it? But one of the key aspects there is this trade-off between fairness and accuracy that always needs to be juggled and accepted when you're deploying machine learning models in reality. Do you develop models that minimize error, like the traditional goal of machine learning, whilst not violating some fairness guidelines that you've built in? And how do you actually manage that trade-off? That can actually be very non-trivial. So beyond data and discovery, the other important aspect is diversity. You need to have cultural and cognitive diversity in your organization to ensure ethical and trustworthy models and AI effectively. So questions around there are, is your team diverse? Does it reflect the diversity expected in your models? Do you have diversity from technical, legal, risk, governance, HR, etc.? And also, do you have gender, age, race, and other diversity? Because ultimately, we do want to have inclusive AI. We want different opinions, thoughts, and views. Remember, data scientists, software engineers are relative newcomers to this topic of ethics, so diverse views are vital to understand AI ethics beyond just the technical components. AI algorithms support us in making better decisions. They don't necessarily make it easier, but it's up to us as humans to define what we mean by fairness, morality, privacy, transparency, and explainability. You can't leave that to the technology. So I've covered the two T's of my success in data science as I see it. You've got trust and you've got technology. The third T is around talking. To me, that is really about communication. That's actually important because the lesson I learned early in my career is that selling analytics is hard. And that can simply mean selling the capability, selling yourself and your own capability within your organization. To get around this, there are some key elements I've identified for success. One is to have the right culture that shares knowledge. You want to be able to share successes, but also failures amongst amongst yourselves, even if it's just from a technical perspective. But broader than that, when it comes to talking and communicating with the business, I find that it's really important to implement proofs of concepts, not just get stuck into a project and say to the your customer, I'll see you in 6 months when we've developed it. You need to have this iterative approach where you're constantly talking, doing small engagements with them, showing them, and asking them, is this viable? Is this what you're after? And then going back, maybe getting extra data, tweaking your model, and so forth. I think doing roadshows as well, if you're in a large organization, making sure that different business units understand what you and your team are capable of. You want to advocate for data science and the AI capability, but you also want to show them that you're really interested and passionate about understanding their data, and you're both there for the same reason, to achieve strategic goals for and outcomes for the organization. Another thing that often helps is doing demos, especially hands-on demonstrations and very visual representations, to make people who aren't data literate understand what is it that you're actually trying to do. So this notion of iterative development with stakeholders, I think, is absolutely paramount. And other things that help you build a willing coalition and trust and support is by having working groups in an organization and working closely with your peers and business units to make sure that you're all on the same page. I also always advocate for my staff to really to ensure that they don't forget the user experience when developing models, to make sure that you may be the most awesome and the fastest and most accurate neural network that they've ever developed, but if it's difficult or cumbersome for end user to actually use it every day, then what's the point? If it's not being used, then it's not really adding value. And when you're communicating with people beyond your technical peers, it's very important not to use technical jargon. Remember, you want to speak in business terms, and you don't want to be talking about ROC curves and technical accuracy. You want to be talking about business, uplift, or dollars saved, or dollars profit increased, etc. Terms and in ways that the business understands. And one important aspect when it comes to actually developing machine learning models in reality is this trade-off between accuracy and explainability. And this really hinges on understanding the business problem and its alignment to a strategy. Sometimes data scientists who are new to the space, they get caught up in trying to build the best, most accurate model possible without really thinking about the ramifications for the business. Will the business owner or group understand how it works? Will they trust it? Will they want to use it? So there's often this juggling act that needs to be delicately balanced, that sometimes you do have to give up some accuracy to ensure that a model is explainable, understandable enough by your customer to actually be used in production every day. So it comes down to the key to transforming an organization to a data-driven culture is really about enabling the ability to make sense of vast amounts of varied data at scale, and to leverage emerging technology to do this. And as I stated through those 3 T's, a lot of that really comes down to people. The people element is really core to all of it. And I think it's important to understand that when you develop these capabilities. So in essence, to create a successful, sustainable, and scalable data science capability that reaps the benefits of AI, you need to invest in all 3 T's. You need to have a trusted, knowledgeable group of people in the right roles in your organization. You need to have the right technology and tools for these people to use. You need to ensure that everyone in the organization is talking, that they're sharing knowledge and ideas to spur innovation. The question I leave with you is, what will you do as an advocate for change to help transform your organization by using these 3 T's? Thank you very much.